supposed to graph the quadratic inequality. So what makes this different from the first 6 problems, 2 things. 1, it's an inequality. It says less than. 2, it doesn't tell you how to do the problem. You can define the x-intercepts any way you want. So to do this, we're going to find x-intercepts, y-intercept, and then find the minimum or maximum for this parabola. I'm telling you that when you do these problems, and it doesn't tell you the order in which to do things, I want you to find x-intercepts first to see if you can factor it. To find x-intercepts, take the boundary of this equation, which would be y equals 3 plus 7x minus 6x squared, and set it equal to 0. Replace y with 0. To find the x-intercepts for this, we're going to see if we can factor it. So we have 3 terms. It's trinomial. The leading term is not a 1. So the proper way to do this is to split the middle term and factor by grouping. This middle term of 7x is going to get split into 2 separate terms. Plus something times x plus something times x. To determine how it splits, you multiply the lead coefficient, -6, times the constant 3. That's a -18. We do 2 things that multiply to get -18 and add to get a positive 7. Those 2 numbers are 9 and -2. So on one of these blanks, put a -2. On the other one, you put a 9. Doesn't matter which one you put where. That is called splitting the middle term. To then factor by grouping, you group terms together that have common factors, making sure that you have a plus sign between your parentheses. Not a minus, not a times, always a plus. Continuing the factoring by grouping, find the GCF of each group. GCF of the first group was -2, GCF of the second group is 3. And then look at your 2 terms, 1 term, 2 terms. They both have a 3x plus 1 in common. So their GCF of those 2 terms is 3x plus 1, leaving us with a negative, oh fudge, there's supposed to be an x up here. GCF of this first group here, -6x squared minus 2x is a -2x. I just wrote down -2. -2x. So here I got -2x plus 3. Sorry about that. And sorry for the language. I said fudge. Set each of those factors equal to 0. So we get 0 equals 3x plus 1. And we got -2x plus 3 equals 0. So we get -1/3 for one of our x-intercepts. And we get x equals 3/2 for the other. So x-intercepts for this, the roots, the zeros, -1/3, positive 3/2. Next, let's find the y-intercept. To do so, take the boundary and replace each of the x values with 0. You find the y-intercept is 3. To find the minimum or maximum, first of all, we know this has a maximum because the lead coefficient is a -6, which means the parabola opens down, which means you have a maximum. To find that maximum, the easiest way for this specific problem will be to find the derivative, which would be -12x plus 7. This is in order to find the critical value, which is the x value of our maximum. We add 12x to both sides and divide both sides by 12. We get a critical value of x equals 7/12. So here is 12. To find the y value of that critical value, to find the y value of the critical point. You plug the 7/12 into the boundary, and you're going to end up getting 121 over 24. I used a calculator. You can use a calculator, but you also should know how to do it without a calculator. So we have a maximum here at 7/12, 121 24ths. We have x-intercepts and the y-intercept, so now we just have to graph it. In graphing this, it says y is less than. There's no equal sign there. So when you make your parabola, it needs to be dashed. Our maximum was at 7/12, 121 24ths. Had an x-intercept of 3/2. Had an x-intercept of -1/3. Had a y-intercept of, what was our y-intercept? It was 3. And then the original inequality says y is less than. Less than, we shade below our curve. So this is our graph. Goes to graph the quadratic inequality. To do that, we need to find the zeros of the function, the roots, the x-intercepts. Then we're going to find the y-intercept, and we're going to find the minimum or maximum. To find the roots, you replace y with 0 into the boundary, so we change it to an equal sign. And the first way that I want you to find the roots every time, if it's possible, see if it factors. If it doesn't factor, then you can complete the square, use the quadratic formula. This factors. We need two numbers that multiply to get -10, 2 times -5. Same two numbers add to get -9. It's called splitting the middle term, what we're doing right now. 2 times -5, once again, is -10. It has to add to be -9. 1 and -10 are numbers that work. So on one of these I'm going to put a 1, on the other one I'm going to put a -10. That's splitting the middle term. Now we're going to factor by grouping. We group terms together that have common factors, making sure, it's so important, that you have a plus sign between your parentheses. Then you find the GCF of each group. GCF of the first group is 2x, leaving us with, pardon me, it's not 2x. GCF of the first group is x, leaving us with 2x plus 1. GCF of the second group is a -2, leaving us with, it's not -2, it's -5, leaving us with 2x plus 1. Now each of these terms, there's 2 terms, both have a common factor of 2x plus 1. So the GCF of those 2 terms is 2x plus 1, leaving us with an x minus 5 or an x plus -5. Notice now we are multiplying these two binomials. Set each of those little factors equal to 0. And if you solve those, you get an x-intercept of -1/2 and an x-intercept of 5. Our roots, our x-intercepts, our zeros of this function are -1/2 and 5. Let's find the y-intercept next. We take our boundary, we replace the x values with zeros. We get a y-intercept of -5. To find the minimum or maximum, and we know this has a minimum, because the lead coefficient is positive, so the parabola opens up. Different ways to do different problems. If you're going to factor it, which we did here, the easiest way to find the minimum or maximum is to find the critical value and critical point from the first derivative. If we set this equal to 0, and we solve this, we get a critical value at x equals 9/4. To find the y value of that critical point, put 9/4 into the boundary, you're going to get -21/8, and once again we know it's a minimum because the lead coefficient is positive. I should be labeling my work a little bit better here. This is to find, like at the top of this, I should put a CV for critical value, at the top of this CP for critical point. The way it's consistent. Here's the roots, here's the y-intercept, here's the critical value, here's the critical point. I apologize for that. So to graph this now, we take all our important information. Our minimum is in quadrant 4, and our boundary is solid because it says y is greater than or equal to 9/4 negative 121/8 is our minimum. X-intercept is 5. X-intercept is negative 1/2. Y-intercept is negative 5. And it says y is greater than, which means you shade above. So there's our graph. We're supposed to graph this. To do that, we're going to find the x-intercepts, we're going to find the y-intercept, and we're going to find the minimum or maximum. To find the x-intercepts, or the roots, you put 0 into the boundary in for y. And then the first thing I want you to do is try to factor it. The two things that multiply to get negative 1 times 10, that's negative 10. Same two things add to get negative 7. And those two things do not exist. There's no two numbers that multiply to get negative 10 and add to get negative 7. So we need to use a different method. So it doesn't factor. I think completing the square is going to be the easiest way to do this. So here's what we're going to do. To complete the square, the leading coefficient needs to be a 1. Right now it's a negative. So from these first two terms, not the 10, just the first two terms, I'm going to factor out a negative 1, leaving us with x squared plus 7x and then a space plus 10 and then a space. To complete the square, we take half of 7, which is 7 over 2, and then we square it. If you add a 7 over 2 squared to the problem, you have to simultaneously subtract a 7 over 2 squared. But be careful. We didn't add a 7 over 2 squared. There's a negative out front. A negative times this makes that a negative. This is really subtracting 7 halves x squared. 7 halves squared. So the opposite of subtracting would be adding. This really is a plus for that reason. If that confuses you in any way, please come see me tomorrow and I will try to explain it to you again. The whole point, a negative 1 in front you can just write as a negative. The whole point of completing the square, so you have a perfect square trinomial, which is going to make this x plus 7 halves quantity squared. 7 divided by 2 squared is going to be 49/4. You square the top and you square the bottom. I'm going to change this 10 to a 40 over 4, so I have common denominators. When I add those together, I get 89/4. Now at this point, once I've simplified this right side and I've completed the square and factored it, this right here is my related equation, my related boundary in the proper form that I know what the vertex is. I ran out of space there. 89/4 should be up there. So that means for us that our vertex is at negative 7 halves 89/4. And we know what's a maximum because the leading coefficient here, this negative, reflects the graph. Continuing with the roots, got sidetracked there. Subtract 89/4 from both sides. Divide both sides by negative 1 to get rid of the negative in front of the parentheses. And we square root both sides. If you square root 89/4, I'm going to continue this work up here at the top. the square root of 89 is not perfect square. So let's just say square root of 89 plus or minus. Square root of 4 is perfect, that's 2. And the right side would be x plus 7 halves. You subtract 7 halves from both sides, and our x-intercepts are going to be negative 7 halves plus or minus square root of 89 halves. To the nearest decimal point, that ends up being something like negative 8 point to the nearest decimal point. That made no sense. To the nearest hundredth ends up being negative 8.22 and positive 1.22 are the x-intercepts. To find the y-intercept, put 0 in for your boundary into the x values. We get a y-intercept of 10. Sorry, I'm getting tired. My handwriting is waning as a result of it. To sum up for this problem, my work is ridiculously organized. I apologize for that. We have x-intercepts of about 8.22 negative and positive 1.22. We have a y-intercept of 10, and we have a maximum at negative 7 halves, 89 fourths. So let's graph that. So we have a maximum, so it opens down. Our vertex is in quadrant 2, and our boundary is solid. So negative 7 halves, 89 fourths is our maximum. X-intercept was about 1.22. It was exactly square root of 89 halves minus 7 halves, 0. And our other x-intercept was negative 8.220. It was exactly negative square root of 89 over 2 minus 7 halves. I like exact better, but most people don't, so I'm just going to put both. The y-intercept we found to be 10, and this graph says less than, so we shade below.